you should be regular. You know your basic is strong, something I found last classes. So if you efforts uh, you if you efforts excellently, you can get excellent result. Your basic, so you have to do work hard. And you, okay, welcome to my class. This is today's, I didn't take the displacement reaction and precipitation reaction. This is 1.12 in the specification. I have shown this specification here. You'll see these things in 1.12 1.12 3 section. You'll see the precipitation reaction are given. These things are given. This is I collect this thing from specification. This is 1.2 1 and 3. This is the 3 precipitation reaction. This is talked here, huh? In your book this is given, specification preference. Okay, this look here. Here was a silver nitrate. When copper added, the solution become blue solution is formed. What is happened here? Okay, you can mute some sound come from. Okay, here this is, it was a silver nitrate solution. Silver nitrate solution. When copper added, this this solution become blue color. So what happened here? And also here form in this oil, look here, formed a silver form. So what is happening here? Have you seen? This was colorless at first. Then when we added here silver copper, it becomes blue color solution. So what happened here? Can you say this? Here copper nitrate solution was formed, and from silver nitrate copper replaced silver and take its position. So new solution is formed. This is copper nitrate solution. Copper nitrate solution is color blue. For this reason, it colorless to blue color turn. This reaction is called displacement reaction. Here what is displacement reaction here? Displacement reaction is in which an element or group of element is replaced by an element or group of element and take its position is called displacement reaction. Displacement reaction, a element or group of element is replaced by the another element or group of element more reactive and take its position is called displacement reaction. Look, this is a reaction in which one element replaces another less reactive element in a compound. A reaction in which one element replaces another less reactive element in a compound. Okay, here the element reactivity look. Potassium, sodium, lithium, calcium, magnesium, aluminum, carbon, zinc, iron, hydrogen, copper, silver, gold. So which this is their decreasing reactivity. So gold is most least reactive, and potassium is most reactive. Okay, most reactive is potassium. So potassium can replace this element. This is less reactive element. So potassium is most reactive and gold is less reactive. Here in a displacement reaction, more reactive metal can replace less reactive metal. Okay, so have you seen this? Look at properly. It is useful For which one is more reactive? Potassium, then sodium, then lithium, then calcium, then magnesium, aluminum, zinc, iron, copper, silver, gold. So which one is the most reactive? Potassium, then sodium, then lithium, calcium. Look, this is a group 1 metal are most reactive. Look, potassium, sodium, lithium. Then group 2 elements, calcium, magnesium. Then group 3 element, aluminum. Then zinc, iron. This is the transition metal. And then zinc, iron, copper, silver, gold. So I have given you clue which are most reactive element. Okay, I'll show this sodium in the chemistry lab. Sodium, I have preserved the sodium in a kerosene, under kerosene. Otherwise you form a reaction with air automatically and from explosion. So this is the most reactive element, the one of the sodium. Okay, so here this is a magnesium and copper sulfate. So which one replace is the replacement occur here? Equation for two displacement reaction of metals. Here magnesium replace copper and take its position. Magnesium sulfate and copper becomes metals. Okay, this is here, and here aluminum displace iron and take its position from aluminum oxide, and iron replaces and from iron metal form. Write ionic equation of reaction 1. Yeah, it is your task. Are you watching screen? Write ionic equation of reaction 1. Write ionic equation. Write ionic equation of reaction 1. And submit to my WhatsApp number. Why have you written this copper 2 here? 2 subscript. This is not here 2 subscript. Why have you written this copper 2 subscript? Copper solid. Have you seen? Are you watching? This is not copper, only copper 2 plus. Here charge is 2 plus, and sulfate charge is minus charge, not minus charge, 2 minus. Here copper is 2. This is subscript. It is not subscript. It will be 2 will be superscript. Here 2 plus. Okay, are you listening me?
Yes, sir.
It will be 2 plus. Copper it will be 2 plus and sulfate 2 minus here. Okay, you have missing there. Where's the arrow sign? You're not finding arrow sign. You given here plus sign. You should give this state symbol aqueous. Okay, you should give here arrow. You missing is arrow. Okay. Okay, look, this is which was magnesium sulfate, not copper zinc sulfate, not copper sulfate. Which one? Copper sulfate. Okay. We know copper here. This is copper. Okay, this your product was this one. Actually, copper, yes, copper and sulfate and this one. Sulfate 2 minus. Okay. Do you know how to write formula? This is formula can be written by swap drop method. Formula writing can use a method is called swap drop method. So at first during writing formula you write swap charge. 2 will come here, 2 will charge replace. Okay, like this is aluminum oxide. Aluminum we know group 3 elements, so positive 2, and oxygen is 2 minus. Okay, we write formula by swap drop method. At first we will swap charge. This 2 will come aluminum and 3 will come to oxygen. Okay, swap this, swap the 2 come to this 2 come here aluminum and swap. Okay, 2 aluminum, sorry, 2. Okay, 10 minutes remaining. If finish, I will take swap. 2 will come here and 3 will come to oxygen. Okay, then I will drop this the aluminum to oxygen 3. Okay, this is the aluminum oxide formula. This way write using swap drop method formula. Okay, this the here I will write swap drop method. So what will be here? This is copper. 2 will come here, and sulfate is group of atom. I'll give bracket. Then drop. Here 2 is both sides, so I eliminate 2, ignore 2, so don't need 2 this given, so don't need also given bracket. This is the copper sulfate. Okay, this is the copper sulfate. So you have missed this. So what will be correct answer? This one, copper sulfate. Have you can solve this problem? Will you solve? And you have another missing. You don't write anything. Directly write. You should write here ionic equation. Then write ionic equation in writing in Word. Okay, you write ionic equation. Okay, there is a reaction though from current is. Okay, some displacement reaction involving halogens. More reactive halogens can replace less reactive. Are you listening me?
Yes, sir.
Okay, more reactive halogens can replace less reactive halogens. More reactive fluorine, chlorine, bromine, iodine. Fluorine is more reactive than chlorine, then bromine, then iodine. Fluorine, chlorine, bromine, iodine. So fluorine is most reactive and iodine is the less reactive in the halogens. Here chlorine replaced bromine and take its position, so potassium chloride is formed, then bromine. Okay, this is the displacement reaction. Look, this more reactive halogens can displace less reactive halogen from their compound. For example, chlorine will displace bromine from a potassium bromide. The full ionic equation. This is the full ionic equation. This is the balanced equation. This is the full ionic equation. This is the simplified ionic equation. Have you seen? I'll give the question. You write the ionic equation. You write these things. If I say write the simplified ionic equation, you write these things, cutting the same things. Here ignore the potassium. This is the look. Remember these things. This is also redox reaction. We know this redox reaction. Why this is redox reaction? Redox come from what? Red come from reduction. Ox come from oxidation. So here oxidation means loss of electrons. Reduction means gain of electrons. So here electrons are transferred in this reaction. Electrons are transferred from bromide ions to chlorine. Bromide ions are oxidized, lose of electrons. So here loss of electrons occur, and chlorine is reduced gain of electrons. So this is also redox reaction. Okay. Another problem. Hi. Iron metal react with silver nitrate in a displacement reaction to form silver and iron 2 nitrate. Write full equation, ionic equation, and simplified ionic equation for this reaction. Okay. Include state symbols in all your equation. Okay, I'll give. Have you understood what will be this question? I'll not give you for writing. You'll write these things by yourself. Okay, I'll give. This is homework. Okay.
Okay, sir.
Because time, for saving time, you'll write full equation at first, then ionic equation, then simplified ionic equation. I have shown here three things. This is the full equation. This is the ionic equation. This is the simplified ionic equation. This way you'll write, also including state symbol. What is precipitation reaction? Have you seen precipitation when two a solution are mixed? Something formed bottom in the test tube. This is called
Yes, sir.
precipitation. In a precipitation reaction, why some bottom substance is formed in the bottom? Because insoluble solid substance is formed. Insoluble solid substance is formed. So solid substance go to bottom, move to bottom. So this is the precipitation. So a reaction in which insoluble solid is formed when two solutions are mixed is called precipitation reaction. Okay, some chemical test, carbon dioxide test. Here is a precipitation form. Here, this is a carbon dioxide precipitation salt, insoluble solid salt is formed. This is the carbon dioxide test. When we'll take a lime water in a carbon dioxide in presence of lime water turn into cloudy, because here carbon dioxide is formed. This is the test for if the lime water going to milky or cloudy, we will understand carbon dioxide is present. Lime water, carbon dioxide turned lime water into milky or cloudy because calcium carbon dioxide insoluble solid is formed. This test is for carbon dioxide test. It's called lime water. Calcium hydroxide solution. Calcium hydroxide solution is called lime water. Look, calcium hydroxide solution. This calcium hydroxide solution is called lime water. Here, white precipitate is formed. Is described as lime water, milky or cloudy. Now look, this is the precipitation lime water, clear lime water. In presence of carbon dioxide, it become cloudy. Okay. This is the sulfate test. Sulfate test in any salt containing, if we add barium chloride, white precipitate, barium sulfate white precipitate form. So this is the test for sulfate. Sulfate containing salt will add barium chloride and barium sulfate white salt is formed. This is the simplified ionic equation for this reaction. Have you seen the simplified equation? My cursor is not working. Well, okay, this is the simplified ionic equation for this reaction. Okay, now halide test. Halide test. Any halide, sodium chloride, sodium bromide, sodium iodide, I will add silver nitrate solution and form silver chloride precipitation, white precipitation form. If the sodium bromide, cream color precipitation form, so silver bromide. If iodine, yellow color precipitation form, like sodium iodide form yellow color precipitation. So this way you can test halide test. Okay, what is the test for sulfate? Sulfate test. Are you listening me? What is the test for sulfate? Hello, are you listening me? Yes.
Yes, sir.
Sulfate test. What is the sulfate test?
Um, Alright,
White precipitate is formed. Okay, thank you. And what is the test for carbon dioxide test?
when the carbon dioxide gas is bubbled with calcium hydroxide solution, the solution turns milky cloud.
Okay. Are you watching my screen? You are watching. Okay.
Yes, sir.
Okay. Now this is an experiment from current pace. Working out equation. We'll find from the reaction. We'll find out equation. Okay. From the test to experiment we'll find the reaction equation. Okay, this is the will balance equation, a good example of using precipitation reaction to work out equation in the reaction between aqueous solution of lead nitrate and potassium iodide. Don't make sound. Both reactants are colorless solution, and when they are mixed, a yellow precipitate of lead iodide form. So we'll here work out an equation. Okay, this what are the reactants? Reactants are, okay, say the what are the product here? Lead they are reactants. Products are lead iodide. Yes. Okay, the substance which participate in the reaction, they are reactants, and which are produced, they are products. Okay, here, okay, these reactants are colorless, and here when these two solution are mixed, yellow precipitate of lead iodide form. This is the yellow precipitate of, so this is solid, maybe solid precipitation. This reaction here, for the reaction you will place volume of potassium iodide solution in the series of test tube. You take 7 test tube. Okay, same volume. Like this potassium iodide volume is 5 cubic centimeter. 5 cubic centimeter, 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 5 cubic centimeter. So you place the same volume of potassium iodide in a series of test tube. Then add different volumes to lead nitrate. This is the lead nitrate different volume. Is a 0.5, 1, 1.5, 2.5, 2, 2.5, 3, 3.5. And here is a precipitation form. When this the potassium iodide 5 and lead nitrate 0.5 cubic centimeter, then precipitation depth is 2.5. Here 3, 4, 5, 6, 6, 6. Here is no change. Can you say why this no change here? From 6, 7, 6, 7, there is no change. Precipitation is remains same. Look, this is the precipitation form. This is the at first precipitation was 2.5 lead iodide, then 3, 3.5, 4, 4.5, this 5, 5, 5 remains same. This is these things remain same. 3, 4, 5, then same. This is the same in test tube 5, 6, 7. 6, 7 why remains same? Precipitation because reaction was completed, there was no remaining reactants to participate the extra reactant extra. Okay, so reaction, the all here all 5 mole 5 cubic centimeter consumed, all finished react with 2.5. This the 3 point will not react, the 5 point extra will not react. Okay, so what is this? So here we see this this reaction to complete 5 cubic centimeter. Which one is double needed? Potassium iodide or lead nitrate?
So I didn't understand the question.
Okay, here and look, 5 cubic centimeter. 5 cubic centimeter potassium iodide react with 2.5 cubic centimeter lead nitrate. So this is double potassium iodide needed. Volume. So we see that in is no increase in the amount from 5 to tube 6, but here 7. This may be mistaken. The reaction is incomplete in tubes 1, 2, 3, 4, but is complete in tube 5. The amount in moles of the reactant used in test tube 5 can be calculated as flow. How can we calculate the moles? Can you know the moles equal to? This is potassium iodide and lead nitrate. Mole of which substance? Reactants are used in the test tube 5. Test tube 5, number of moles of reactant are calculated here. How this calculated, this one? Do you know the how to find the mole concentration?
No, sir.
Moles equal to concentration okay, and I should write this way. This one concentration. Okay, for I space for space some space for multiplication sign. Concentration multiply volume. Volume must be liter. It is liter. It will be liter. So here this was reaction is, what are the reactant? What are the reactants? Was silver nitrate or potassium nitrate? Okay, reactant was silver nitrate and potassium iodide. Silver nitrate and potassium iodide. So silver nitrate and potassium iodide. And another information is here missing, maybe.
No, sir, lead nitrate.
Oh, lead nitrate. Yes, lead nitrate and potassium iodide.
Potassium iodide.
Okay, here concentration of both solution is 1 mole per cubic decimeter. Per cubic decimeter. Have you seen the concentration? Concentration of both solution are given. That means
Yes,
1.
sir.
Concentration of both solution is 1 mole per cubic decimeter. So concentration is given. Okay, set this equation. In the 5 question was find out the concentration is in test tube 5. Okay, test tube 5. This is test tube 5. Where is test tube 5? Test tube 5. Test tube 5. How much volume of to reactant? Volume of potassium iodide 5 cubic centimeter. Potassium iodide 5 cubic centimeter, and lead nitrate 2.5 and 5. Okay, this is the cubic centimeter. Okay, a concentration is given cubic per cubic decimeter. Do you know what is the relation decimeter, cubic decimeter and cubic centimeter?
No, sir.
Okay, 1 cubic decimeter equal to 100,000 cubic centimeter. Cubic decimeter and cubic centimeter, cubic decimeter and liter are same. One liter equal to 100 cubic centimeter. 100 cubic centimeter. Okay, 100 cubic centimeter equal to 1 liter. 1 liter is also called 1 cubic decimeter. These are same. 1 cubic decimeter or 1 liter are same. Okay, or these are same. So I should convert the volume at first. Okay, concentration is 1. Lead nitrate, first reactant is lead nitrate. So concentration of lead nitrate, I am not finding lead nitrate. Concentration is this is the concentration of lead nitrate. No, sorry, number of moles of lead nitrate. This is the N. Okay, what is the concentration? 1. Okay, concentration 1. What is the volume lead nitrate in test tube 5? Lead nitrate volume in test tube 5. Have you seen what is the volume of lead nitrate in test tube 5?
2.5.
2.5. Okay, so this is the cubic centimeter. Have you seen? I must convert into cubic decimeter. So what can I do? This is the given cubic centimeter. I must convert into cubic decimeter. So what can I do? 2.5. This is given 2.5. If I convert into cubic decimeter, I must divide it by 1000. Okay, cubic decimeter 1000, then it become cubic decimeter. Okay, so what is this? Have you used calculator? 2.5 divided by 1000, it is 0.0025. 1.0025. That means 0.0025 mole. Okay, the moles of 0.0025 mole. Okay, lead this way. Okay, this is 0.025 lead nitrate, number of moles of lead nitrate. Have you understood these things? Lead nitrate, how this lead nitrate found? This is the lead nitrate, this one, 0.02 this one. Potassium iodide you will do by yourself. So this show that lead nitrate react with potassium iodide 1:2. 1:2. Potassium iodide is double. Okay, it is 1:2. Have you seen from this reaction? 1:2. So the equation for the reaction are, so here why this is potassium to here double? 1:2. Potassium iodide. Okay, so this is the here is written 2 I has a 1. So this is reaction. We work out a reaction equation. Have you seen? This is the full equation. This is the simplified ionic equation. Okay, class is going to finish. Homework. You write the simplified ionic equation including state symbol, this one and this one also given. Thank you for joining class.